Okay, guys, I'm going to explain orbital overlap. And you have already done phase simulation, right? So what we got? We did here neon interaction studies, and also we did here oxygen interactions, right? This one is oxygen interactions. So so what we got here? When we did our study with neon interaction, we got, you see, this is your zero line, this is your zero line, and these two neon atoms are far away from each other. So when you bring them together, we saw, so the atoms were oscillating between this point and this point, right? It's going back and forth. And when you brought them very close to each other, the atoms were kicked away, right? So now you see why the atoms were kicked away. So kicked away means there is repulsive forces. So FR, repulsive forces, is mass higher than the attractive forces, FA, right? So how do you get repulsive forces? When the atoms are very close to each other, so their nucleus are also very close to each other. So you have nucleus repulsion, and the sandwich electrons are also very close to each other. So you have electron repulsion. So this collectively give you much more repulsive forces than attractive forces, right? So, and repulsive forces are positive because you have nucleus repulsion and electron repulsion. So minus and plus, they give you positive. So repulsive forces are positive. So that's why you got here very sharp rise when the atoms are very close to each other. So now what's happening here? Here we see the nucleus are not too much close to each other, but you have lot of electrons sandwiched between the nucleus, right? So there is orbital overlap, and because of this orbital overlap, you have sandwich electron, and these sandwich electrons are attracted by both nucleus, this nucleus and this nucleus, right? So you have lot of attractive forces here, here, right? You have a lot of attractive forces that are working on the electrons, and these electrons are actually penetrated like electrons of one atom has penetrated the orbitals of another atom, right? And because of this penetration, you know, the effective nuclear charges like ZEF is drastically increased. And when ZEF increase, you have also lot of nuclear pool, right? This is nuclear pool, right? This is nuclear pool. And because of this nuclear pool, you have a lot of attractive forces than the repulsive forces. So attractive forces are negative, right? You have the attraction between nucleus, right, and electron and nucleus. In both cases, you get negative value, and this is your attractive forces. You see, it is below the zero line. That means they are attractive forces, right? And what's happening here? So when the atoms are away from each other, you have equal amount of attractive forces and equal amount of repulsive forces. So attractive forces minus and repulsive forces plus. So this will give you zero, right? So that's why they are close to zero. So now what's happening with oxygen? You see the oxygen, when the orbital of oxygen overlap, right? Overlap, you have very drastic fall of energy, right? Energy. So why this is happening? Here you have to consider two factors. Number one is sandwich electrons. You have orbital overlaps and you have sandwich electrons between both nuclei, right? So these sandwich electrons will be attracted by this nucleus and this nucleus, right? And when in the outer shell of oxygen you have 6 electrons, but when they are overlapping, right? So they are sharing 2 electrons, and this way they are completing their octet. So when the atoms complete their octet, this gives them additional stability, right? So one way you have penetrated electrons attracted by both nuclei, and this gives you huge increase in ZEP, effective nuclear charge, and also the huge increase in nuclear pool, right? This is nuclear pool. And because of this, you have huge amount of attractive forces that overpower your repulsive forces. That's why you have negative value. So attractive forces are negative, repulsive forces are positive, right? So when the two atoms are very close to each other, and we saw here also they are kicked out. Why kicked out? Because there are lot of repulsion between nucleus and nucleus, electron and electron. So your repulsive forces is much more, right? This is much more higher. This is much more higher than your attractive forces, which is between nucleus and electron, or electron and nucleus, right? And here you have attractive forces and repulsive forces. They cancel each other. They're equal, right? Attractive forces negative, repulsive forces positive. So 0. So I hope you understood it. If you still have problem, please keep in touch with me. I will explain you further. And I will also send you a video link. Thank you so much.